Welcome to your MN10 notes. Measure and classifying angles, which is section 1.4 in your geometry textbook. Let's start this section by defining what an angle is. An angle consists of two different rays with the same endpoint. This diagram in the example I'm going to label as A. It's right here, which we call the vertex. Is going to be B. This point on the ray over here is C. So you see that we have two rays starting at the vertex endpoint, the same endpoint B, and going through A and then it's going through C. These we call sides of your angle. One thing I'm going to mention right now to help us with example 1 to understand it is that we name an angle by saying, using the angle symbol, angle. In this case, I'm going to say ABC represents my example angle to the left. The other way you can write it is by changing the order of your letters, but the middle letter is always going to be your vertex. So we could also say this is angle CBA. So those are two ways of naming that angle. One other way, a nice shortcut way, is just by naming it by its vertex. So you would say angle B. That's a nice way of doing it, so it's a little bit easier. But notice in all cases here, the vertex is in the middle of your name. Here, the vertex is in the middle name. And then over here, when we name that angle by just the vertex, it's letter B. Example 1, name three angles. Let me get some letters on here first. This right here is going to be W. This over here, let's call it X. Notice I'm using all capital letters. This right here is Y, and down here is point Z. To name three angles here, we can say a couple things. We can look at the entire big angle and say, hey, we have angle WXZ. That's one way. And keep in mind, we could also, that same angle, we could have said it's angle ZXW. So we could have gone either direction with that. Again, notice X is our vertex, so that's in the middle of our angle notation. Another way we could, another angle we can say is angle WXY. So talk about that upper small angle. And again, what we could have said for that one as well is angle YXW. Some of you may want to say, hey, one of the angles is angle X. So we can put that, and that is a big no-no. And here's the reason why. You can't say angle X like we did up above where we said angle B, because angle X actually comprises of more than just one angle. As you notice, this has a vertex with angle X, this has a vertex with angle X, so you can't just say angle X. So that's a no-no. So I'll let you know that, because that's an easy mistake to make. Our third angle that we can use is that lower angle, which is going to be, let's say, angle ZXY, or again, if you prefer writing it as YXZ, that is absolutely wonderful. So those are the way you name angles. The bottom table here, it says example 2, filled in the table below. We're talking about acute angles, right angles, obtuse angles, and straight angles. And folks, I know that this is definitely a review of earlier math courses. I'm going to have you take a little bit of time right now and define each one, draw an example of each one, and then the example you draw, measure that using a protractor that you have or you can borrow from me. So at this point, I'm going to pause the video to give you just some time to work on this. So you can pause it as well. Okay, so this, I filled out the table, and you want to check yours with mine. And again, if you're having some questions on this review material, you can definitely check out section 1.4 of the textbook, which does have all of this laid out as well. But acute angles, of course, are less than 90 degrees. Here's my example right here. and I didn't measure it with a protractor, but I'm going to be just looking at about 28 to 32 degrees. The right angles are always going to equal 90 degrees. Here's my display right here. Notice I'm using this little box in the corner. That implies 90 degrees, that it is a right angle. You have obtuse is greater than 90 degrees, and you would measure it, and of course you would looking at line again, it's going to be about 120-ish degrees. You're going to measure yours accurately, of course. And then the straight angle is your essentially a straight line, but it's 180 degrees. So if you use your protractor from this point to this right here, it's going to be 180 degrees. Hopefully that's a good review. Flipping on the other side of your note guide, you'll notice that we're first going to define what an angle bisector is. And over here I have this angle. I'm going to label this as X, this is Y, and this is Z. An angle bisector, as we've talked about with segment bisector, anytime you hear the word bisect, it means break it up into two equal pieces. So now we're talking about an angle bisector. So we're taking this angle given and breaking it up into two equal pieces by bringing a ray through it. This ray I'm going to put as point B on that ray. And I'm going to use a notation that we tend to use in geometry, or at least in this textbook. I'm going to put one arc here and then another single arc here. And that's implying those two angles are the same. If one of those angles had one arc and the other one two arcs, then the notation is clearly giving you information that they are not equal or congruent. So over here on the right-hand side, it says angle XYB is blank to angle BYZ. If you look at your angle over there, what they are is congruent. So angle bisectors, an angle bisector breaks an angle into two congruent pieces. Angle addition postulate, again, going back to segment addition postulate, really is saying that if you have a big angle and you break it into two, you can add those two angles together and get the size or the degree of your big angle. So I'm going to say this is point R, this here is point S, this is point T, and this right here is point P. So here it says angle RSP. So RSP is right here. I'm going to put a single arc there. And if you add that to PST, which is this angle here, which clearly doesn't equal. We're not talking about an angle bisector here. We're just talking about two angles. If you add those two angles together, what you're going to get is the sum or the angle measure of this up here, this entire angle. That's a postulate. Why? Because it's a rule that we believe in without any kind of proof. Example 3. So use that angle addition postulate. It says given measure of angle LKN is equal to 145 degrees. Before I read any further, let me actually put some letters or some points on this these angles. This right here is L. This right here is K. This up here is M, and this right here is N. And it says, given LKN, so we're talking about the big angle, is 145 degrees. Find the measure of LKM, which if you're having trouble reading it, I'm giving a hint there in parentheses. You say it's read as measure of angle LKM. And M, which again stands for measure of angle MKN. What we do need, though, is some more information here that is on your note guide, but I don't have it right on mine, so I'll put it down real quick. This angle is represented by the expression 2x plus 10 degrees. This one is going to be 4x minus 3 degrees. Now, we don't know if these are equal, so I'm going to say this is measure, and over here, we're just going to say it's not the same measure. But using that angle addition postulate, we do know that the measure of LKN, plus the measure of MKN is going to equal the total measure, the big measure, which is LKN. So essentially, you're just adding your two inner angles together to get your entire angle measure. So LKM is represented right here as 2x plus 10. MKN is represented right here as 4x minus 3. And the measure of LKN, the big one, the main big angle, its total measure is up here at 145 degrees. So all I'm doing is using substitution, substituting what I know for each angle. So I substituted 2x plus 10 in for the measure of LKM, the 4x minus 3 in for the measure of MKN, and 145 degrees, which was given to us, in for LKN. And now I'm going to solve this. So I combine like terms. I have 2x here, 4x here, gives me 6x. I have 10 here, minus 3 here, so we have plus 7. Let's combine my terms equals 145. I solve for x by subtracting 7 from both sides. So I have 6x equals, that's 138. I divide out by 6 on both sides, so undo my multiplication, solve for x. And x equals 23. Now, this is the unknown. This is the variable that we just solved for. It's not necessarily the degree. Remember, if you want to find the measure of LKM, I'm going to bring this over here. So the measure of LKM is actually represented by 2x plus 10. Now, since we know our x value down here, which is 23, we can now substitute that in for x. And solve it to find out what the actual measure of that degree is. And 2 times 23 is 46 plus 10. We have 56 degrees. So the measure of LKM is 56 degrees, which I'm going to put right up here. Now you have two choices to find the second measure of that MKN. We could either say, hey, we know the big angle is 145 degrees. Oops. And we know the smaller angle is 56 degrees, so if we use our number sets, we can subtract those and get the measure of 89 degrees. Or you can substitute that 23 right in for x for LKM, and I'm going to just come right up here. I'm going to go 4 times, instead of x, I'm going to put 23 in, minus 3. And if you calculate this out, you're going to also get 89 degrees. This angle right here. Now remember, the sum of the two angles has to be 145 degrees. Make sure you check that it's actually working. So these two angles added together should equal 145 degrees. Well, I hope that helps you out for section 1.4, and we'll go through any questions you have in class.